Kia ora tātou. Ko Christy Atkins aho. Ko te kairahi kei te mātauranga o CEDA Tuku Mahi. Tēnā koutou katoa. Welcome to our webinar. We are talking today with Emmeline and Eric from SpaceBase. So it's very exciting, talking about careers in the space industry. And I know they're going to introduce themselves properly soon, so I'll leave that task to them. But a bit of housekeeping. This webinar is being recorded, so you can re-watch it, and it's available to be shared with your friends and family who you think. It'll all be available on sortexpo.co.nz. For those of you who are watching live, you will have the opportunity to ask Emmeline and Eric questions directly. So please feel free to pop any questions you do have in the chat box on the right-hand side, and at the end of the presentation, we'll make sure to answer those. And for anyone watching, you'll also be able to have a handout of the slides that Emmeline and Eric are showing us today. So there is a lot of information, but don't worry, you'll be able to go back over that later. Right, so Emmeline and Eric, thank you so much for joining us. We're really privileged to have you speak to us about space today. I will hand straight over to you.
Yeah, thank you, Christy. Let me just share my screen here. Cool. All right. Well, kia ora. Again, I'm Emmeline Pat Dahlstrom, and this is Eric.
I'm Eric.
And we're a couple. So basically, we are, just to give you a little bit more of a background about us, about 3 years ago, we moved to New Zealand from the US, and we're Edmund Hillary Fellows. And so just a little bit more of a background about ourselves. We basically have a space and aerospace backgrounds for over 3 decades. We've worked in the space, public and private space industry in the US and in Europe. We wear kind of like different hats while we're here, so we still maintain our global networks as well. So we'll give you a little bit of a background of kind of like our career paths too. So, and also we came to New Zealand basically with a very long-term goal of the democratization of access to space, and we do this by trying to catalyze the space industry in developing and emerging countries, starting in New Zealand.
All right, just to introduce myself and tell you a little bit about my space career. I started, I followed pretty much of a technical track. I started in physics and astronomy, being very interested in black holes and things like that. But then, and I was going for a PhD in astronomy, but I gave up on the PhD because I got interested in all sorts of things space related. And I switched over into space engineering, working on the design of the International Space Station and studying shuttle safety and working on satellite design and things like that. And one message from this is that my interest remained the same even as I pursued these different paths. And it's also interesting that a few of the jobs I ended up having did not exist when I first started studying things. And so I think that's going to be true for anybody interested in space careers, is that the job that you may end up working on probably doesn't exist yet now, but you just, your interest will guide you.
So going over to me, so I'm originally from the Philippines, and Eric and I kind of like started from very similar backgrounds. I also did an undergraduate in physics, but I turned out to be kind of like I worked towards a different career path. I did my master's in Earth and Space Science, but also got the opportunity to study at the International Space University in France, where basically after that, I also worked primarily on space education and program development. And so having worked on more operations and management, I also worked in kind of like the space tourism business. So there was a company called Space Adventures, which is the very first tourist company to send private citizens to the space station. And I was basically the director for program development and operations for a number of years there. And then later on, I basically also worked for another space educational technology institution, which kind of like helped startups to birth also space startup companies. And so I was now kind of like more focused on space entrepreneurship, and even had a chance to basically write a book on the future of space. But when we were growing up, there was like really not a lot of opportunity if you're not working towards a career that has some like government basically position, so being an astronaut or a cosmonaut. But times have really changed now within the last kind of a decade. There's essentially this exponential technologies or accelerating technologies like AI, robotics, biotech, nanotech, all of these technologies that are based on computing. And computing has been accelerating and changing. Like every 2 years, it doubles in basically the price performance. And so any technology that is moving in the same way or is based on computing will also be accelerating there. And because of these technologies, it has really democratized sort of the access to space technologies as well. So one case in point, if you think about your cell phone, and this is actually an iPhone 7. We're now on iPhone, I guess 11 or 12. But just this one cell phone here, if you combine all of the computers that were used during the Apollo era, this one cell phone is about 240 million times, even much faster than all of those combined computers, which is really just like an amazing thing to think about. And we forget that we got like supercomputers in our pockets. So just to even like narrow down, because this space technologies and the space industry is pretty broad. So let's just like look at the satellite industry. So about 3 years ago, when I was comparing satellites, we always compare satellites with huge, big and expensive satellites that need to be launched by really big rockets and launchers. Today we got CubeSats, which are the size of a shoebox. But then today it's really now the comparison is between like a pocket sat and a chipsat. So it's really getting smaller and cheaper and better, and especially it's becoming off the shelf. So here's just like one example of how this CubeSat or shoebox size CubeSats are now being deployed, even just through the International Space Station. There are sometimes the cosmonauts would even basically just toss them out of the airlock. So very, very different from how we were kind of like launching them like a few decades before. So let's just like look at the anatomy of a CubeSat. So if not to oversimplify it, but you can think about your basic Arduino, which is the basic computer, and you add sort of like sensors that are as small as your cell phone, and then you just like need an antenna or some communication electronics that could make your CubeSat actually talk to the ground. And that's really the basis or the basics of a CubeSat. But today, space exploration and the space industry is no longer just for exploration and science, which is also, of course, a very good thing. But today we're really looking at satellite technology that is helping us solve problems on Earth. So this is one example. Precision agriculture today is leveraging satellite technology to make sure that we kind of like know the health of crops today and also monitor basically food yield. In other areas, the entire like global maritime and shipping industry is based now and heavily relies on satellites. Where if you look at all of these dots here, those are essentially represent each one of those ships that are flying like globally. And if one of those transponders actually flicker out, then there's a potential for a likelihood of really illegal activity, which is why this is also very important for fishing and monitoring fishing activities kind of like globally. Another application as well is like using AI and also machine learning. We're now using and leveraging satellite data to also predict and mitigate and also understand the behaviors of wildfires, which is of course very important today. We just had really bad season of wildfires in Australia at the beginning of the year. But I think maybe the kind of the biggest application here, which we're now kind of like seeing, is all of this constellation of small satellites that are being launched up there to really provide broadband internet. So this is a game changer. In the past, and actually currently today, there's half of the world that really does not have internet or broadband access. And this is essentially going to be a game changer if they manage to actually launch all of these satellites and have constellations for communication and have broadband for places where in the past it's really just cost prohibitive to have infrastructure be built to have access to Wi-Fi. So going back to New Zealand, so we're still looking at the satellite sort of like industry, and today there's actually a number of companies already leveraging satellite technology for their own core business using satellite applications. And so there are companies in New Zealand that are leveraging satellites like to track species, to also looking at like weather, and then also on the data analysis side, once the data has been brought down from those satellites, there's a lot of applications of those data to solve like problems here on Earth, and these are actually the logos of companies that already exist in New Zealand. So also with the satellite sort of market and boom, it also created this small satellite launch market, which didn't exist before. So just to think about this, in the past, we only had like big rockets where you would have to wait for when that big rocket actually has to launch for your satellite to actually be launched in space. And they're normally pretty expensive. So, but today there's now small launchers, just like Rocket Lab, who can then launch smaller payloads because the satellites are getting smaller, and they're now cheaper, and they can also launch more frequently than before. So the example here is like it's like as if you're no longer going a scheduled bus, but you're actually using an Uber to go where you wanted to go.
And Rocket Lab is really in the lead in this area, and that's New Zealand is really known in the space world for Rocket Lab's advances in the small satellite.
Yeah, it's interesting because New Zealand is actually now very well kind of world renowned because of Rocket Lab, and Rocket Lab is in the lead. So there's about 150 different companies all over the globe that are trying to do what Rocket Lab has done today. So I wanted to show you this slide. I think it's very important to also kind of like share that the life cycle of a satellite is not just the engineering part of it. So we always think about the, the manufacturing, the integration, and the testing, which is sort of like indicated here. But really, kind of like the life cycle starts from when you design the payload and what experiments or what sensors you're going to be needing to put in there before you start manufacturing, integrating, and testing. And then before you can actually launch your satellite, you have to license your satellite to make sure that it actually is within the requirements of launch. And then once you launch, you need to maintain that satellite up. And so therefore, there's mission operations and management that needs to happen all throughout the lifetime of that satellite when it's up. And then also with the data that's coming down, those are going to be used for applications. You need data analysts to be able to understand the data. And then you need also people to be able to create basically products and services out of those data that you get from the satellite.
And all these different areas are different space careers. You can, people specialize in one little piece of each of these things.
And so you don't just need to be an engineer. You can be in law for focusing on the licensing. You can be a technician and an operations person if you're like focusing on the launch and operations side, or on the business side with either marketing and sales as well. And all throughout this, there's of course management that needs to happen from beginning to end. So I talked about really just kind of like one vertical of the space industry, which is on the satellite side. So if you look at this slide here, this is more looking at like the full spectrum of the space industry. We talked about satellite sensing, spacecraft data analysis, and sensors. And then most of the time when you think about the space industry, you're only thinking about rockets and rocket ships or spacecraft. But there's other areas here, from life support to robotics, habitations for like future missions and space servicing, and even further down the line, which is like resources and mining. So I guess the point here is to say that whatever your interest is today, even with like terrestrial industries, there will always be a part of that interest that is applied to the space industry. And so there's like lots of opportunities that are kind of like happening. So I just wanted to go back to New Zealand. When we first got here like 3 years ago, the first thing that we wanted to know is like, well, where are the organizations or companies and industries that are actually having some activities. And so we created a directory. And originally we thought that there's just going to be like, a dozen organizations that are actually working in the industry. But we found about like 240 plus organizations and companies that are actually all over New Zealand, that on one shape or another have some activity related to space. And so if you look at this slide here, there's already some clustering of some of the markets and capabilities in the kind of like the regions within New Zealand. So for example, in Christchurch, where we are, there's a lot of like component manufacturing. There's also, propulsion research, and data analysis, while up in Auckland, there's a lot of activity that's in kind of like in the pursuit of nanosat development and research. While if you go to like Napier area, of course, with rocket labs and the launch pads, the launch operations is really kind of like more top of mind there. And that directory that we created was sort of like the baseline to the Deloitte report that was created last year, which was focused on really the New Zealand space economy. And the summary is that there's about $1.7 billion already being contributed to the New Zealand economy of all of these activities that are currently happening today, and direct employment of 5,000 FTEs. So if you look at this, I just wanted to point out, because most people would basically say, well, maybe that 1.6 billion is really because of Rocket Lab's operations here. But actually, if you look, that 1 billion out of the 1.7 billion is on the space applications side. Not just on space manufacturing and space operations. So which means really shows that on the application side and on the data analysis side, there is a lot of opportunities here that are already kind of like existing in New Zealand.
Yeah, now I wanted to talk about some of the larger term, long-term trends, and then also go through a lot of different areas that are at different aspects of the space industry. And the idea is that if you find one or two things that interest you, that can lead you, if you follow them through, that can help direct your entry into a space career. And so one aspect is that around the world there are some really big plans for SpaceX has these Mars settlement plans. Blue Origin is focusing on the moon. United Launch Alliance thinks that they're going to need 1,000 people just for propellant stations out at the moon in 30 years. So there's the companies and national governments are really scaling up activities. Another area that's exploding now is the application of space robotics. There's been a handful of really high value robots on Mars, but there's a number of companies that are developing sort of mass-produced and large-scale robots for any of these exploration missions and science missions. They're looking at not hundreds but thousands of robots in the future. Another area that's transformed rapidly. 10 years ago, we had some of our students formed a company, Made in Space, and built 3D printers that operate in zero gravity. And they've got 5 3D printers on the space station right now, and they're getting ready to fly ones that operate out in the vacuum. And so they have plans for building really large structures where you just make use of the raw materials in space and just transmit the designs electronically. And in the longest term, there's still some work going on with preparing for collecting energy in space and actually beaming it back to Earth. And one of the few, we'll mention one of the few companies that's looking at making solar cells out of lunar material is based in Auckland. But this transformation of the exponential technologies has really made sensors and generally sensors that are used on Earth but can be applied into space, that are these components that used to be $50,000 space hardware is now $3 chips that you can order and you experiment with. And so there's a transformation of using some low-cost electronics that are used for on terrestrially and applying them for space systems. There's one of the biggest applications in space is remote sensing of the Earth, and there's a lot of opportunities to examine what you can do with that. But there's also opportunities to see about testing out new sensors on things like drones and aircraft, and before they're flown into space. And so things like hyperspectral sensors or laser range finders and microwave sensors, things like that. And so that's a big industry of everybody who's testing what's useful for monitoring agriculture, for example, and how can you test it on the ground before you fly a spacecraft. And one of the in recent years, the access and entry into data analysis of space data has really dropped it used to be, 10 years ago that you needed a $50,000 dedicated computer and software, and now it's you can get free software that runs on your laptop. Your laptop's powerful enough, and free data and access especially from the European Copernicus system and the U.S. Landsat and things like that. And people are developing new applications and new tools for data analysis and building companies out of those. There's a number of ones operating in New Zealand that are developing new machine learning tools, for example. There's all across New Zealand, there are companies that are making parts for the rocket lab. Unfortunately, they can't talk about them publicly, but there's a lot of other companies that have expertise in precision engineering that for other applications that are at the same scale of quality and precision as needed for space parts. And so there's a lot of opportunities for where if you can't find a company that's making working in a space job, you can actually work for a company that or learn techniques on precision engineering, and then you're ready for a career shift later on for when companies do start making space parts. Another thing that New Zealand is well known for is the logistics and operations for Antarctica, for the New Zealand government and the U.S. government and several others. And this, I think, is going to be very valuable in the future as we start supporting lunar base activity and eventually Mars base. New Zealand is also uniquely leading the way in terms of policy and regulations, with small teams developing innovative regulations responding to commercial needs. And it's another area where there's people don't realize that there's an international industry in some sense for space policy and law. There's a lot of interest right now in New Zealand for developing more space testing equipment, various shaking things, and for the experience of launch for a satellite, or thermal cycles and rocket engine tests. And there's a lot of expertise and companies that do various kinds of testing for the aviation industry that directly apply.
And it's interesting that terrestrial testing is actually more complicated than space testing.
Yeah, space testing is just a subset. It's just a certain number of kind of vibrations and things like that. There's the entire biotech and pharmaceuticals are huge industries, of course, on Earth, but there's certain space aspects that are very interesting. There's one thing is that a lot of biological materials behave differently in microgravity, but then on the user needs side, this is identified as one of the big areas that NASA identifies as a problem, where the medicines, for example, will not last all the way during a Mars mission, and so they need some way to produce medicines in space, and so it's basically an unknown right now. And there's a lot of these things that are, if you dig deep, you discover that NASA really doesn't have a solution, and they're looking for solutions. Another area that's specific for New Zealand, it turns out that the closer you get to the poles, the more benefit there is for ground stations to collect data from especially polar orbiting satellites. And so there's the southern tip of New Zealand has a lot of ground stations for collecting data from polar orbiting satellites. And then also Leo Labs, a US company, has installed a space debris tracking radar on the South Island. And so there's a number of opportunities in the future where people are learning just for terrestrial, microwave and cell phone tower technologies and getting ready to apply them for space activities. There's an wide open area in the future is the manufacturing of material using material in space on the moon and Mars or asteroids. And we have a couple groups in New Zealand that are getting ready for building structures on the moon or solar power photovoltaic arrays. And there's and they're both, they're basically applying knowledge and lessons from terrestrial manufacturing on the ground to into the strange space environment. And so they're in the labs with the aspiring materials or in the using vacuum chambers to make solar cells. And with all these activities for renewed activities for lunar base and Earth orbital space stations, suddenly there's a lot more architecture and structures design. So there's new designs coming out all the time about dedicated low Earth orbit facilities for manufacturing or for tourism or other applications, and so that this area has not been there's not been a lot of work in that in the last few decades, but now suddenly there's an explosion of new designs and new design concepts.
So and essentially just to add, like today we only have the International Space Station, which is of course government run, but because again of the technologies that are being democratized, and now there are private companies that want to create their own space stations and space hotels, which is why design and architecture for these types of infrastructures are also another opportunity.
And related to the next slide, also the nanoracks is just announced today design concepts for a agriculture space agriculture focused research lab in low Earth orbit, and so we'll come back to that. But certainly one big area of activity in New Zealand with a number of different groups is the propulsion, both for the Earth to orbit rockets like Rocket Lab, but also for and Dawn Aerospace, but also in orbit propulsion for satellites and even microsatellites. And New Zealand across the country has a number of things that are related to things like dark sky tourism and things like that. And so there's activities all over the place that are interested in these activities. I mentioned this with the agriculture, that this remains a really critical need and a big unknown, and something that may be an opportunity for New Zealand to look at applying high productivity extreme agriculture in extreme environments, of which space is a special case. And so there's things like self-contained urban farming, closed environment farming,
or vertical farming.
Yeah, that's the term I was looking for. Vertical farming. There's experiments in Antarctica about growing food, and there's but it's a very early stage on the space side, and NASA identifies this as a really critical path for any Moon or Mars base.
Yeah, and I just wanted to just emphasize this because, like, if on the space side it's like more long term, but today, especially with climate change and everything that's like happening with what's happening on Earth, where we are really going towards like extreme environment, and at the same time we still like globally, you still need to have the same productivity rates and production of more food yield. So this is really kind of like important, because it's the same technology that you apply for needing to create those food production technologies, which is really needed today, which will then be applicable to like space related missions in the future.
And just as the announcement today from the United Arab Emirates that they are linking their efforts to research food production in the desert with food production in space. And so they're basically funding the design of a research lab, but I don't think they know what to put in it in terms of experiments, so that we need the agriculture expertise. And also in the long term, there's the resources the asteroids and the moon for mining is a long-term opportunity, and there are a lot of people that are trying to look at, can you apply the lessons from the terrestrial mining and learn how to do this in these very different environments. So just as a summary of some of the things that are going on related to that may relate to future lunar base activity. We have lunar solar power with Extraterrestrial Power Limited in Auckland in the lab developing solar cells. We have some research on food production at University of Canterbury, and we have I mentioned the Antarctic base logistics experience. The University of Canterbury Department of Energy and Engineering is working on lunar landing pads, lunar concrete, and even the first mission for the NASA Artemis program is actually going to be launched by Rocket Lab from Virginia and into the HALO orbit.
So as we kind of like wrap up the presentation, Eric talked about those like long-term aspirational types of activities that New Zealand can certainly be a part of. This one is more kind of like short-term, and if you look at this slide, there's a lot of what we pointed here, which could be short-term future for New Zealand, is already happening. And I kind of like I mentioned earlier on with the directory, where there's like a clumping of already existing kind of like capabilities within regions. I think this really kind of like shows the potential within the next like 2 to 3 years of where each of those regions can really be part of the space industry, and kind of you as an individual can also look at all of these opportunities and see where your kind of your passion and your interest lies, and inquire on where you could potentially fit. My last kind of like slides here is just like some space resources, and so this one are resources online, and as we said, we're giving you the PDF of this presentation with hyperlinks, and just wanted to point out. And so for example, with SpaceBase, we also do a podcast, and I normally interview people from New Zealand who's had careers in space, and just like trying to understand like how do they get from when they started to where they are now. But there's a lot of like other opportunities for learning online. Like for example, with the Space Academy, that's the biggest video repository of space courses that's gamified and it's free. That was created by one of our students before. So there's a bunch there, and then also just on tertiary and academic institutions and opportunities in New Zealand. If you're kind of like leaning towards a certain interest, like if you're interested in engineering or mechatronics or robotics, University of Canterbury is kind of like known for that. If you're interested in doing more like satellite manufacturing, then University of Auckland Space Institute, which also has the APSS program, has it. And like other also non-science kind of like based like degrees and programs as well in the different universities. And just to point out that there are existing NASA internships right now for NASA Ames in California and also Jet Propulsion Laboratory that is available through the New Zealand Space Agency. And then also Rocket Lab has their own scholarship. So I'm going to end here with a quote. So the best way to predict the future is to create it yourself. I think it's really important to kind of like work on something that you're passionate about, and also I would say that, you know, dream big, because there's a lot of things that are happening today that are really exciting, especially in the space industry field. So this is also how you can contact us. So we have a website, then also there's a Facebook group where we actually post like a lot of the New Zealand space related news on there as well. And we also have like this free course that is on thinkific.com for catalyzing a space industry kind of like in your region. And then of course our emails. So I think we'll end there. And if there's any questions, we'll definitely be happy to answer.
Oh, thank you both so much. That was so great, so helpful. I don't know how you managed to jam-pack so much information into such a short presentation. So thank you all again. We do actually have a question that's come through from Neve, and she just says thank you again for talking with us. She is a medical student with a keen interest in robotic assisted surgery. She's saying she's always wanted to apply this in aerospace medicine context. Given your experiences, she was wondering if you had any advice about how she could move forward meaningfully in this field, or even where she could get some good information. Thank you.
Yeah, I think we can also add more contacts by email. I think, but I think, yeah, this is really an important area that, and it's going to be especially vital for anything out to the lunar scale. People are looking at being able to do telerobotic. If you're out to the Mars distance, the crew is really on its own, and you might get advice from a doctor, but it's that's also recognized as one of the huge challenges for a Mars mission, because basically the crew has to bring along the expertise along the way. But we do know a number of people who are doing these experiments and with teleoperated, extending the Da Vinci telerobotic surgery to longer and longer distances. So it's maybe we can put you in touch with. I think once you latch on to an interest like that, then you find the people that are working in that area, and not all of them will be helpful, but most of them will be helpful, and we'll be happy to guide you as to especially getting up to speed on the research papers and finding out who's doing the work in the area.
Awesome.
Yeah, that's good.
Right. Well, Neve, so Eric's contact details are part of that presentation, but if you do have any trouble finding them, please just get in touch with us through the SORT Expo website, sortexpo.co.nz, and we can put you in touch. Now, I actually had a bunch of questions, which I feel like lots of them have now been answered, but a quick one for you. I think lots of people, when they think about space as an industry, it seems like such a futuristic, far off field. So what would you say to, potentially we might have young people watching this who are really interested in space, but their parents aren't quite getting it? What's some advice that you would give either to that student or to their parents around some of these future career opportunities that are very real?
Yeah, it's we've in some sense since the Apollo program 50 years ago, we've almost been put to sleep as far as the pace of space activities. I mean, I worked on International Space Station. That's tremendous. It's a huge facility, but I don't think we realize how much an expansion of activity is going to happen in the next 5 or 10 years. I mean, right now, in Texas, there not only are there three different companies in the U.S. are testing lander vehicles for going to the moon, but SpaceX is testing a vehicle that can carry 100 people to the moon at once. And so it's just the transformation. It's like we're just at the stage where the space industry can outrace the government programs.
Yeah, and the timelines are really short. So normally people would say, "Oh yeah, we're going to the moon." Well, we're going to the moon maybe in 10 years or in 20 years again. But actually, these companies, as Eric was saying, the private industry has a much faster time scale than government missions, and so they're looking at like within like half a decade here. So yeah, between the next 2 to 5 years, there's a lot of things that are going to be happening. And as I mentioned before, when I talked about exponential technologies, we always think of things as a linear path of change, but it's actually exponential. So which means that you might think that it's going to be really far off, but actually it's not. And so we need to make sure that we don't get disrupted by all of these changes that are happening. And as I mentioned, all of the things that are, especially on the satellite, the satellite technology, like vertical segment of the space industry, they're all of them are about applications to Earth applications that we need today. From like disaster relief to kind of like agriculture to monitoring, kind of everything that is needed basically today, as opposed to like in the future. So yeah, there's definitely lots of things happening, and if you're now is kind of like a great time, especially if there's like students in the audience here, like trying to think about career paths, because as I mentioned, with everything moving and changing so fast, that there are jobs that basically that we haven't even thought about, but in 2 years' time they're going to exist, and so therefore you really need to kind of work backwards to say that you would be competitive for those jobs in 2 to 3 years' time by starting kind of like today.
Yeah,
and that's sort of like the trends that we're already seeing.
And it sounds like what I'm kind of picking up is that people who might have skills in other industries actually would relate quite well to what we're needing in the space industry as well. So do you think there's going to be opportunities there for people who are looking to change up their career or make a shift?
Yeah,
I think so. And it's and one thing that's been remarkable is that the space industry has continued to grow like at 20% a year, even and not even slowed down by COVID. Yeah, so it's and so that's something where the opportunities just keep on increasing, and the if you have an interest and you just monitor things, you may be able to jump over it at the right spot.
Yeah, and just like what we were showing with the slides, where there's terrestrial and space, and that's really what we're alluding to, where all of these adjacent industries are essentially the same technology, but you just apply it into extreme environments, of which space is like one subset of that. And so yeah, I think today it's no longer, you don't have to go back to university and do another like 4-year degree in something. It's more of a pivot to what already the skills and the training that you have, to focusing it on a space related product or service.
Which is really exciting, isn't it?
Yeah.
We have one of our followers or watchers today, Ali, she is saying she's planning a move to New Zealand. She's currently a software engineer, but has lots of contacts in space due to her son. She said she's just watching to see if there are any options for her in her tech field. And what kind of advice would you give to someone like Ali who's looking at moving to New Zealand? I know you touched on, I mean, there's over 200 companies working in space already, which blows my mind a little bit. What advice would you give to someone like Ali?
Well, you mentioned that her background's in software.
Yes, software engineer.
So for at least for me, the low-hanging fruit here right now is data analysis, and so which is kind of like the easiest way to break into the industry, because again, it's the same training for data analysis. Terrestrial data analysis is kind of like the same way that you're gonna just leveraging satellite data as opposed to terrestrial data for all of like these different applications. And I also showed like the slides of the companies that are now in New Zealand, and I think the most number of companies in the space field is the ones that are in the data analysis and satellite applications.
And they're spread around. You know,
Yeah.
the Christchurch, Wellington, and Auckland all have space data analysis companies, and a lot of them are, you know, it's such a broad area that they're specializing into, you know, monitoring buildings or road planning or geosciences or environmental sciences, or the space challenge that we ran, the aerospace challenge last year was focused on using satellite data to detect pollution from agriculture and land and water, and some the software solutions were the ones that won it. So it's, yeah.
The Earth Space Challenge, it sounds really interesting. Is it something people would find via SpaceBase website, or how would they go about finding something like that?
Yeah, so we did the National Space Challenge back in 2018, and then also the Aerospace Challenge back in 2019. There is none this year. There is just we basically were delivering it for Christchurch and Airbus from the past 2 years.
I think we have the results on our website, right?
But if you go on our website, there's still the link to the Aerospace Challenge from last year, and so we're hoping that there would be more like in the next years as well. I think there's the factor of COVID that happened this year that kind of, I think
derailed
a little bit.
But the companies the teams that competed in the Aerospace Challenge last year and the winner sequence are linked through the website.
Yeah.
Right.
Yeah.
Oh. Well, I mean, talking to just the two of you, I don't know anyone else who works in space, but it seems like it's full of passionate, enthusiastic people. So I think if you two are anything to go by. So we just want to say thank you again for your time, Eric and Emmeline. We really appreciate it, and I'm sure everyone who's watching this does as well. Any last final piece of advice just before we run out of time?
Well, I just think that there's just so much opportunity. If you're passionate about space, don't be deterred by thinking that it's way too far, or it's like just above your head. Like, everybody can actually be part of this growing industry, and we look forward to where New Zealand is going to go, especially with the younger generation.
Yeah, and I think you'll find that globally the space community is very encouraging of people to come in and even, you know, change around and follow their interests. It's not like, you know, people are not, you know, pushing you out or things like that. They're trying to encourage you. So it's pretty good.
Oh, cool. Oh, that's really great to hear. Thank you again so much for your time. And thank you to everyone who's joined us today. As I said earlier, this webinar has been recorded, so you can come back and rewatch it and share it with your friends and your family as well. And we'll also put up the slides so that you can get some of that awesome information that's been shared. I think myself, I'm going to go off and listen to some of those podcasts. They sound awesome. Cool. Thank you all. Have a great day.
Thanks for having us.
Thank you.
All right.
Thank you.
All right.
Bye.